particle P lies on a horizontal plane. Three horizontal forces of magnitude 7, 12 and 16 newtons acting in directions as shown in the diagram are applied to P. Show that the magnitude of the resultant of the three forces is approximately 7.9 newtons. Find the angle between the direction of the resultant and the direction of the 12 Newton force. The particle P has mass 5 kilograms and the coefficient between P and the plane is 0.1. Taking the magnitude of the resultant of the three forces to be 7.9 newtons, calculate the magnitude of the acceleration of P. So mu was equal to 0.1, wasn't it? That's what we've got there. Here's our forces then. So the resultant force, so let's have a look at A. Horizontally then, let's resolve the forces. We've got 12 minus 16 cos 60, which is sine 30, which is a half, is equal to 12 minus 8 is 4. Vertically, let's look at vertically, we've got 7 minus 16 cos of this angle, which is sine of this angle. Sine 60 is root 3 over 2, which equals 7 minus 8 root 3. Let's just tap that in the calculator. 7 minus 8 times root 3. Decimal. Minus 6.856. Minus 6.85 and so on. So there's the forces then. So resultant force is equal to this squared using Pythag plus this squared, 6.85 dot 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 squared is equal to, so let's type it in the calculator then. So if we just square this answer, we get that, plus 4 squared, which is 16, equals, so that's in the answer now, so square root the answer then, 7.94 to 2 dp. Oh, 7.9, and that would be to 1 dp, wouldn't it? So there's what we wanted then, 7.9 newtons. Find its angle to the 12 Newton force. Okay, so here's our 12 Newton force here then. We went along 4 to here, and then we went down 6.85, didn't we? So there's the angle then. This was 6.85. So the tan alpha is equal to 6.85 dot 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 divided by 4. So that will tell us what alpha is. Shift tan of this. Now I'm going to put that in the calculator again. So 7 minus 8 root 3, 8 times the square root of 3 equals, so it's in the answer now, so it's that divided by 4. Okay, and then we shift tan it, inverse tan of the answer, and it's it was a minus, but we can ignore that because it's just the angle we're interested in. 59, well, let's just get it back, 0.7 degrees. That's to 1 decimal place. So there's the angle it makes to the 12 Newton force. Okay, so part B. P has mass 5 kilograms. Find its acceleration. So here's the particle. It's got mass 5, and the force acting on it is in that direction here. Here's the resultant force. Mu r acts against it. I've called that r because that's the resultant force. But here we've got a resultant, which I'll call mu r dashed, where r dashed is the normal reaction. So here the normal reaction vertically, F equals ma then. So apply that vertically gives. So what have we got then? We've got R dashed will be the reaction off the ground is equal to mg, which is 5g. Now we can apply resolving in that direction, F equals ma now gives this force here, which we've got as 7.9, minus mu r dash, which was 0.15 times 5g, 5g over 10 then, because that's 0.1, times, divide by 10, so that's the force is equal to the mass, 5 times the acceleration. So this 7.9 should still be in the calculator. No, it's not. Where did the 7.9 come from then? It's this. So maybe I could just... No, I'm going to have to get it again. So let's just get that again then. 7 minus 8 times the square root of 3. Decimal. Square that. Equals plus 16 equals, and then square root the answer. So we got back our number. 7.93 is our resultant force. Minus 5g over 10, which is g over 2, isn't it? Which is 4.9. So that minus 4.9 equals. So the acceleration then will be that number, which is 3.037, divided by 5, because that was the number, and then we move the 5 from times to divide. So we just do that number, answer, and divide by 5. No 0.61, isn't it, to 2dp? 0.61 ms minus 2, and that's the 2 decimal places. And that was part B, wasn't it? Find its acceleration. There we go. 0.61 meters per second per second.